So we applied a mass balance over a control volume for a component A. We take a control volume and we apply a mass balance for a component A. The mass is entering from this phase with the edge E and leaving with the edge G. So the resultant equation gives this expression MA multiplied by curl NAX over curl X plus curl NA over curl Y plus curl NA over curl Z plus rho A over curl theta is equal to MARA, where Ma is the molecular weight of the component which is entering from in the cube. Na is the molar flux. Nax is the molar flux of a component from x direction velocity. Nay is the molar flux of component A from y direction velocity, and Naz is the molar flux of component A from z direction velocity. And curly A over curly theta is the rate of change of density per unit time, and Ra is the rate of reaction. So we have done a component balance for a component A. Similarly, we can do component balance for a component B, and for component B, it gives MA curl NAX over curl X, sorry, curl NB X over curl X plus curl NB Y over curl Y plus curl NB Z over curl Z plus curl rho B over curl theta is equal to MBR. Say, give this equation number 8. This is equation number 9. Adding both equation 8 and 9 gives adding both equation 8 and 9 gives curl MA NA plus MB NB in x direction upon curl X plus curl MA NA plus MB NB over curl Y plus curl MA NA NB MA NA plus MB NB over Z over curl Z plus curl O over curl theta is equal to 0. So this is equation number 10. This is a combined mass balance equation for component A and B. And kindly bear in mind that this rho is a combined solution density such that rho is rho A plus rho B. Now, since we know from the basic mass transfer equation, we know that Na is NaXA plus Ja. Question number 11, where Na is the molar flux, NXA is due to bulk movement of the fluid, and J is the diffusion, molecular diffusion. So, for component A, we can write multiplying both sides with molecular weight Ma, MaNA is equal to MaNXA plus MaJaX. And we can write this MaNXA as Ux into rho A plus MaJa. Give this as a question number 12. Now, what we have done, instead of Ma and Xa, we have written Ux into rho A, where rho is the density of fluid and Ux is the component velocity in x direction. And Ux is defined as Ux is mass average velocity such that rho Ux is UA into rho A plus UBX into rho B. So what we have done, this UA is the component A velocity in the x direction and rho is its density of component A. UB is the velocity of component B in the x direction and rho B is the component B density, and this rho is the bulk average density and Ux is the average velocity, such that Ux is UAX over rho A plus UB x rho B divided by rho. Now, we can also write this to equal as MA NAX plus MB and BX. Give this as a question number 13. Now, take a question number 12. Question number 12 and take differential both sides with respect to x. Now take a question number 12, question number 13 and differentiate it with respect to x both sides. Since rho and ux both are variable, we will differentiate according to differentiation rule of differentiation of two differentiation of multiplication of two variables. So it will become curl MA NA plus MB NB over curl X is equal to, so this is coming from this and this will become this side and this will become rho curl Ux over curl X plus Ux curl rho over curl X. This is question number 14. So the equation number 10 becomes, substitute equation number 14 in equation number 10. So MANA plus MBNB is replaced by rho curly ux over curl x plus ux curly rho over curl x. It becomes, this is x derivative, this is y, this is z, and this curl rho over curl theta. So यहां पर एक कंपोनेंट x के लिए आ जाएगा, y के लिए आ जाएगा, z के लिए आ जाएगा, प्लस कर्ल रो ओवर कर्ल थीटा इज इक्वल टू 0. So equation number 10 becomes, with the use of equation number 14, it becomes rho curl u x over curl x plus curl u y over curl y plus curl u z over curl z plus ux over curl rho over curl x plus ui over curl rho over curl y plus uz curl rho over curl z plus curl rho over curl theta is equal to 0. This becomes equation number 15. So if solution density is constant, all derivative of density with respect to all variables becomes 0. So it will become 0, it will become 0, it will become 0, it will become 0, and hence all this becomes equal to 0. It implies for a solution of constant density, curl u x over curl x plus curl u y over curl y plus curl u z over curl z is equal to 0. This relation is very important, and this is called equation of continuity for a total substance. So moving ahead, and again using equation number 14 in equation number 12, using equation number 14 in equation number 12 gives differentiating equation number 12, differentiating equation number 12 gives MANA x is equal to ux rho a plus MAJX. Differentiating gives MA curl NAX over curl x is equal to UX over curl rho a over curl x plus rho a curl UX over curl x plus MA curl jx over curl ax. So this is equation number 12 and this is equation number 17. Now we can write JA in the terms of JA is minus DAB curly C over curly X. So substituting this in this, there is already one derivative, it will become double derivative. So it becomes ux over curl rho x, curl rho a over curl x plus rho a curl ux over curl x minus ma dab curl square c over curl x square. This is equation number 18 and this is ma over curly na x over curl x. And then similarly writing the similar equation for component a for x direction, y direction and z direction, it becomes ux curl rho a over curl x plus uy curl rho a over curl y plus uz curl rho a over curl z plus rho a common curl ux over curl x plus curl y over curl y plus curl z over curl z minus ma dab curl square c square over curl x square plus curl square ca over curl y square plus curl square ca over curl z square plus curl rho a over curl theta is equal to ma r. This becomes equation number 90. So what we have done, see equation number 18. ma and x की जगह ma so go back to equation number 8. This is equation number 8. So we will substitute ma na over curl x plus ma curly na over curly y plus curly na over curly z. We will replace it with the equation number 18. We will use equation number 18 in equation number 8 and then all this for component a, for x component, y component and z component is equal to plus curly rho a over curly theta is equal to mara. So it becomes, if a solution is of constant density, we have just derived for a solution of constant density. What we derive for a solution of constant density, curl x, curl ux over curl x plus curl y over curl y plus curl z over curl z is equal to 0. So we will use this equation number 16 in equation number 19 and it gives this becomes 0. So it will vanish and we got the equation this plus this is equal to this plus this. So it becomes ux curl CA over curl x. How we are writing curl CA? We are writing CA because we have multiplied with density rho A and divide by MA to give concentration. So it becomes ux curly C over curly x because rho because rho A into MA is CA because rho क्या है मास पर यूनिट वॉल्यूम और ये क्या है मोलिकुलर वेट वेट per mole. So it gives because this is kilogram per mole and this is kilogram per meter cube. It gives concentration. So concentration is moles per unit volume and moles per unit volume कैसे derive कर सकते हैं हम density kilogram per unit volume divided by molecular weight divided by molecular weight. It gives concentration. So concentration Ca is density divided by molecular weight. So we can write equation number 19 as ux Ca over curl x plus uy curl Ca over curl y plus uz curl Ca over curl z plus curl Ca curly theta is equal to dab curl square Ca upon curl x square plus curl square Ca upon curl y square plus curl square Ca upon curl z square plus r. This is equation number 20. For a special case where velocity is zero and there is no chemical reaction, it reduces to where there is no reaction, this term vanishes, and velocity is zero, this term velocity, this reduces zero, this zero, it becomes curl Ca upon curl theta is equal to dab curl square Ca upon curl x square plus y square plus z square. This is called Fick's second law. This is frequently applicable to diffusion in solids. Compare this with energy equation.